Hello, fifth graders. Yes, it's Mrs. Tremblay again. And today we're going to look at comparing fractions. So you need the two sheets that are attached to this assignment. And the first sheet should say Unit 1, Lesson 4, Comparing Fractions up top. Again, there are 2 pages. You'll end up, the ones I pass out in class will be cut, but you'll end up wanting to trim along the sides here. And you'll be putting these into your math journal. You don't have to worry about that right this minute. For now, let's get going. All right, so there's 4 basic different scenarios when you're trying to compare fractions, and we'll be doing this a lot in class. This is gonna really help you when it's time to add and subtract fractions, when you need a common denominator. So this is just phase 1. Okay, so when we are comparing, we're talking about greater than, less than, or equal to, right? When 2 fractions are equivalent, they're equal to. So sometimes when you see some fractions, you want to ask yourself some questions. And the first question you should ask yourself is, are my denominators the same? Because if your denominators are the same here, like 5/8 and 3/8, denominators are 8, the pieces are the same size. And when the pieces are the same size, the fraction with the higher numerator is greater because you have more of the same size pieces. And you can see here, if we just did the pictorial example, these are both eighths. Right here we can see this is a larger chunk, right? So 5/8 takes up more space than 3/8. And if you didn't have the picture, we could just say, hey, those are both 8s. These are the same size pieces. If I have more pieces, I'm gonna take up more space. So why don't you go ahead and try these 4 and press play to make sure your answers are right. Okay, welcome back. If you do get any of these wrong, I do want you to erase and fix, because you're gonna put these in your journal, in your math spiral, and I want you to have a bunch of correct things to look back at. All right, so notice I have 3/4, 1/4. These are the same size pieces, so having 3 pieces would be greater. Here, 7/8 versus 3/8, same denominator. Having 7 of those pieces versus 3 shaded in, 7 will be greater. Here, my denominator is 17. If I have 10/17 versus 12/17, 12/17 would take up more space. And here, I know these are improper, but it's okay. The denominators are still the same. And if I have 6 out of 5 of those same size pieces versus 8 out of those same size pieces, 8 would be more. So the lesson so far, if you're comparing 2 fractions and you see that the denominators are the same, that's my favorite kind. The higher numerator is greater because you have more of the same size pieces. Okay, now let's say you're looking at 2 fractions and you notice, okay, denominators don't match, but the numerators are the same. So if you're comparing 2 fractions and you notice, hey, both of those numerators are the same, the fraction with the lower denominator will be greater because the pieces are larger. And this has to do with when we compared unit fractions. Remember on your fraction bar diagram, if you can kind of picture back, we had like 1/2 and then 1/3 and 1/4 and 1/5 and 1/6, and those pieces kept getting smaller and smaller and smaller. Well, unit fractions all have a numerator of 1. That means their numerator matches, right? And we said the lower the denominator, the less people you share with, so you get bigger pieces. So if my numerators match, the one with the lower denominator will be greater because you are getting 3 larger pieces. So you can see here, 3 out of 4 is definitely more than 3 out of 8. This is the same size whole. This one takes up this much space, this one only this. So go ahead and you can press pause and then press play after you're done. Try these examples. Okay, so for letter E, the 9s match. Here I have to share with 10 people, here 12. My pieces are going to be bigger with the 10s. For letter F, 1/7 versus 1/5. If I'm only sharing with 5 pieces, I'm gonna have bigger pieces here. For letter G, the numerators match. This one's cut up into 8, this is 11th. These pieces are bigger. And 9/8 versus 9/4. Again, I know these are improper, but I want you to understand that this works for improper fractions too. My numerators still match. This, the whole's cut up into 4. This, the whole's cut up into 8. These pieces are larger. Okay, so far you've learned to compare fractions with the same denominator and the same numerator. You should always be asking yourself when you're comparing 2 fractions, are my denominators the same And then if they're not, the second question you'd ask yourself is, are my numerators the same? Because those are the quickest strategies. Like if you ask yourself those questions, that will get you to the answer a lot faster, to be noticing that. Okay, get the second page in front of you. And this one starts off with comparing fractions where one denominator is a factor of the other. And remember that factors are numbers we multiply together to get a product, right? So this says, create a comparison of the fractions with the same denominator by multiplying one of the fractions. So right here, I have 5/8 and I have 19/24. And yes, you could draw two of the same size whole, and you could cut this one up into 8 pieces and shade 5, and this one up into 24 pieces and shade 19, but that would take forever, okay? So if you think back to our workbook page, and I have mine handy, so I'll just show you. When we had 3/4 and I wanted to make it 8ths, didn't we just ask ourselves 4 times what would give me the 8? And we cut it up into that piece, those number of pieces, and multiply both of the fractions by it to create an equivalent. This is the same thing, guys and girls. If I'm looking at this, I have 5/8 and 19/24. We learned that if our denominators are the same, that the fraction with the higher numerator is greater, right? I'd have to say, and I think you'll agree, that's the easiest way to compare when the pieces are the same size, right? So in looking at these denominators, 8 and 24, is 8 a factor of 24? Meaning, can I multiply 8 by something to get 24? Yeah, I can. Just like in that one, I could multiply 4 by something to get 8. 8 times what is 24? 8 times 3, right? So if you multiply this 8 by 3, and I'm going to go backwards this way because I don't have enough room there. 8 times 3 is 24, right? Now I want an equivalent fraction, so don't pull a puzzle penguin and just bring over that 5. To create an equivalent fraction, I'd have to multiply the numerator by the same thing. 5 times 3 is 15. So what we just did was we created an equivalent fraction where the denominators match, right? So instead of comparing 5/8 and 19/24, I can compare 15/24 and 19/24. And now it's way more obvious which one's greater, right? The pieces are the same size, 19 would be greater. So in order to answer these questions, and if you want to press pause, you already feel good about it, fine. Maybe you want to wait till I do one and then you can do the rest. Or maybe you just want to do all of them with me, that's fine. In looking at this, I would still ask myself, number one, do my denominators match? No. Do my numerators match? No. And now I'm going to look at my lower denominator and ask myself, is my lower denominator a factor of the higher denominator? Meaning, can I multiply 6 by something to get 12? And the answer is yes. I can multiply 6 by 2 to get 12. So I'm going to go ahead and I'm going to multiply 5/6 by 2 over 2. So the 5 times 2 is 10, and 6 times 2 is 12. 5, 6, and 10, 12 are equivalent, right? So now, instead of comparing 3/12 and 5/6, I can compare 3/12 and 10/12. What's more, 3 out of 12 or 10 out of 12? Where these pieces are the same size, 10 would definitely be greater. All right, letter J, my denominators do not match. My numerators do not match. Is 4, the lower, a factor of 8, the higher? Yes, I can multiply 4 by 2 to get 8. And if I multiply 4 by 2, I need to do the same thing to my numerator. 3 times 2 is 6. So I'm really comparing 6/8 and 7/8. Now my denominators match. I can see 7 is greater. For letter K, my denominators don't match. My numerators don't match. Is 6 a factor of 12? Yeah, we just did that here. 6 is a factor of 12. I'm going to multiply 6 by 2, and that will get me 12. And if I multiply 6 by 2, I have to multiply 5 by 2. And we get 10/12. So what's more, 11/12 or 10/12? 11/12. All right, and then I have 5/7 and 13 over 21. The 7 and 21 don't match. The 5 and the 13 don't match. Is 7 a factor of 21? Can I multiply 7 by something to get 21? Yep. 7 times 3 gives me 21. And if you multiply the 7 by the 3, you better multiply the 5 by the 3 or you're not going to get an equivalent fraction. 3 times 5 is 15. So now we have 15 over 21 versus 13 out of 21. What's more? The 15, because these pieces are the same size. Okay? So if one denominator is a factor of the other, you can just multiply one of those fractions to get a denominator that is the same. All right, the last one here, comparing fractions with just straight up different denominators, and you're gonna notice that one is not a factor of the other. So in these, 6 is a factor of 12. 4 is a factor of 8. But when you look at this, is 7 a factor of 8? Can I multiply 7 by something to get 8? No. Nope, I can't. So what do you do then? Well, you can multiply each fraction by the opposite fraction's denominator over itself, because you have to do the top and the bottom, to create common denominators. So here's what I mean. When you look at this, every comparison problem you see, you should ask yourself, do my denominators match? No. Do my numerators match? That's your second question. No. Third question, can I multiply the lower value by something to get the higher value? Is 7 a factor of 8? And if that answer is no, here is what you do. I'm going to multiply 4/7 by the opposite fraction's denominator over itself. So the opposite fraction's denominator is 8. I'm going to multiply 4/7 by 8 over 8. And I'm going to multiply 5/8 by the opposite fraction's denominator, 7 over 7. So I took 4/7 and I multiplied it by that denominator over itself, and 5/8 and multiplied it by that denominator over itself. And watch what happens when you do this. 8 times 4 is 32. 8 times 7, 56. 7 times 5 is 35. 8 times 7 is 56. Guess what, my friends? The denominators match now. And now I can compare 32 over 56 with 35 over 56. What's more? 35. Once those pieces are the same size, it's super easy to compare. All right, so let's try a few. I have 1/8 and 2/5. Do my denominators match? No. Do my numerators match? No. Is 5 a factor of 8? No. So I'm going to multiply this fraction by the opposite fraction's denominator over itself, and I'm going to multiply this fraction by the opposite fraction's denominator over itself. When we do that, this is now 5 times 1 is 5, 5 times 8 is 40, so I have 5/40ths, and this would be 8 times 2 is 16, 5 times 8 is 40. Now our denominators match, and we can see that 16/40ths would be more than 5/40ths, because 16 of the same size pieces would be more than 5 of the same size pieces. All right, look at letter N. My denominators, do they match? No. Do my numerators match? No. Is 3 a factor of 7? No, I can't multiply 3 by anything to get 7. So what do? We multiply each fraction by the opposite fraction's denominator over itself. So the denominator here is 3. I would multiply this by 3 over 3. And the denominator here is 7. I multiply this by 7 over 7. And a common error that I see is people keep the denominator the same and try to multiply this by 7 over 7 and this by 3 over 3. If you do that, you're going to notice at the end the denominators don't match. So when you do this, 3 times 5 is 15. 3 times 7 is 21. I now have 15 over 21. And here 2 times 7 is 14. 3 times 7 is 21. Do you see how now my denominators match? That's what should happen after you multiply. So if you didn't pick the right numbers, you won't get a matching denominator, and you'll know, oh, I need to go back. So what's more, 15 out of 21 or 14 out of 21? 15 is. Right? Maybe you want to try these two and then press play. Maybe not. It's up to you. All right, so my denominators don't match. My numerators don't match. 5 is not a factor of 6. I know 5 plus 1 is 6, but I can't multiply 5 by anything to get 6. So I'm going to have to multiply 5/6 by the opposite fraction's denominator over itself. And I'm going to have to multiply 4/5 by the opposite fraction's denominator over itself. My new fractions are 5 times 5 is 25 over 5 times 6 is 30. And 4 times 6 is 24, and 5 times 6 is 30. Okay, so I can see that 25 out of 30 is more than 24 out of 30 because my denominators match now. All right, last one. I am going to multiply, well, first, sorry. I just know it's in this category, but my denominators don't match. My numerators don't match. 8 is not a factor of 9. I can't multiply 8 by something to get 9. So I'll need to multiply 6/8 by this fraction's denominator over itself. And I'll need to multiply 7/9 by this fraction's denominator over itself. All right, 9 times 6 is 54. 9 times 8 is 72. 7 times 8 is 56. 9 times 8 is 72. Which one would be more? 56 out of 72 is more than 54 out of 72. All right, now you know how to compare fractions in any situation. Great job, guys. See you soon.